Good afternoon. This is the video for pump troubleshooting. The purpose of this video is to provide a cause and effect presentation of some of the most common problems that we might encounter during our pump operations. The solutions to these problems will also be presented. Some will be quick and easy, and others will be a bit more involved. Whenever we encounter a problem during a pump operation, we use the progression supply, pump, discharge. This is a quick and easy to remember method for analyzing and assessing the issue in a high stress environment. So we will start with supply problems. In AFD we use two types of water supplies. The first is our onboard tank water. A problem that can be encountered when using tank water is a partially or totally closed tank to pump valve. The second problem is an empty tank. They will both present in the same way, cavitation. Keep in mind that our frontline apparatus have a sensor that will bring the engine RPMs down to idle if cavitation is detected. The solution for the first problem is to simply open the valve all the way. For the second, we need to get more water from an external source. If our tank to pump is completely open with water in the tank, but we are still having signs of cavitation, pull the primer. There's probably some air in the pump that needs to be expelled. The second type of water supply we'll use during a pump operation is an incoming pressurized supply. Hydrants, tank transfer, tandem, relay, and dual pumping all fall into this category. As we know, in these situations we cannot be fooled by what seems to be a relatively high static pressure. A problem on the supply side will only manifest itself after we begin flowing water in the form of an inaccurately low residual pressure. When we suspect an issue on the supply side, we will start at the engine and work our way back, looking for possible restrictions in flow. First, we check the intake valve, making sure it is open all the way. If there are any kinks in our supply hose, we remove them. When using a manifold, ensure that it is not partially closed. And finally, check that the hydrant is fully open. Another supply problem that will present in the same manner is debris in our intake strainer. The fix for this issue is not quite as straightforward. In this case, we have to shut down the supply and either remove the obstruction or move the supply to another intake. Once we have mitigated these problems, we will observe a more accurate residual pressure. Pump problems. This is where we go in the progression after we have ruled out an issue with the supply. The most common pump problem is not engaging the pump into pump gear. There are a few different indicators of a properly engaged pump, including 2 green lights on the pump shifter or a reading on the speedometer when the truck is not moving. But the most fail-safe way to check is by increasing RPMs and seeing a corresponding increase in the discharge pressure. If we do not see this increase, we need to go back to the cab and engage or re-engage the pump into pump gear. Water coming from the bottom of the engine can signify a problem that needs to be remedied. A lot of water coming out under a lot of pressure is indicative of an improperly set intake relief valve. When this occurs, adjust the relief valve to the proper setting. A little bit of water coming out under pressure means there is an open drain valve. Simply close the valve. A lot of water coming out under a relatively lower pressure means your tank is full, but your tank refill is still open. If this is not intended, close your tank refill. Once we have ruled out the supply and the pump as causes for our problem, we move on to the discharge side. Similar to the supply side, on the discharge side, restrictions in flow will cause problems. A decrease in flow will result in an increase in the pressure we see on our individual discharge gauge. The decreases in flow can be attributed to one of two things: a kink in the attack line or an obstruction in the nozzle. If the issue is a kink, fix it. If there is an obstruction, remove the break apart fog tip for a smooth bore stream. In contrast, an unintended decrease in discharge pressure implies an increase in flow. This can occur as a result of a burst line or an open gated Y. Another common mistake on the discharge side is opening the wrong discharge valve. Always take the time to double check. We'll end the presentation with a couple of photos. This picture is from a multiple handline skills test. During the evolution, the pump operator noticed an unintended increase in discharge pressure. After walking the line for kinks, he noticed that the flow from the attack line was reduced and the shape of the stream was distorted. Inside the fog nozzle was a rubber gasket. This was a potentially serious problem that was quickly mitigated because of supply, pump, discharge progression. Issues can and will arise. Make sure you are ready for them. Thanks for watching, and as always, if you have any questions, don't hesitate to contact us.